Okay, welcome to Vaayusastra Aerospace Future Scientist Meet, chapter number 27. Today we have a rainy day, Sunday. Chennai is almost flooded. Even though, despite of all these things, we have our future scientist meet. And we have all the presenters here. We have two new presenters and we have more than 20 participants, a lot of people watching it in live. And here we come with a lot of positivity and a lot of energy. Whoever feel frustrated of rains or drained of rains, here is some positivity for you. Okay, so welcome to Vaayusastra's Future Scientist Meet. This is chapter number 27. Like every week, we have 6 presenters today. Out of the 6, 2 are the first time presenters. That's the amazing thing about this is both are Harinis. One is R Harini, one is D Harini. And both are selected students of this group of schools. Out of say, I think 7 to 10 schools, they given us 70 students. So these are out of 7,000 to 8,000 students, there are selected number of selected students. Okay. So for those who are watching it for the first time, so what is Vaayusastra? Vaayusastra is an IIT Madras incubated startup to spread the awareness of aeronautics and aerospace among school children and college students using hands-on methods and storytelling methods. So what we do, basically we train all the students using hands-on methods. So I'm just what happened. Then during this pandemic, we came up with this new thing called Trigger the Spark. Trigger the Spark. Okay, I'm looking at my image in live. It's totally white background. I don't know how to put this poster in the background. Anyway, let it be. Where are we? So during this pandemic, we came up with something new called Trigger the Spark, where we researched about life of a lot of scientists, where there's a moment in their life which triggered the spark. Surprisingly, it has something to do with stories, toys, and games. So we created a methodology to train students using. We tell a lot of stories with a lot of science and some simple hands-on models. It worked out very well. We got very interesting, super duper results. So we got a bunch of say 5 to 6 students who came up with the new company names. They have their own CEO, one CTO. Even one student registered his own company, and one student finished her own book. And we have a lot more to show now. And so this future scientist is a what is the result, is the outcome of this Trigger the Spark. So after completing all the levels, after completing all the levels, they will put in something called Young Researchers Group, where we used to practice, where we make students to do research on some specific topics. And they used to do presentation. We used to do some exercise. But suddenly, accidentally, one day I pressed live option in the Zoom, and we went live, and we got a lot of audience from all over the world. Not all, like we did not publish it, but still we got some 200, 300 audience watching it from a lot of districts. So then we thought, okay, let's take this students' potential to more places, and we started doing it properly from then onwards. We still now completed 26 chapters. Today is 27th, and even we got some guests from space agencies come and visit us, some investors come and visit us. So a lot of these things happen. Okay, so anyway, quickly let's start today's presentations or research works by our students. the first presentation. Those who are watching this regularly definitely familiar with this name. So that is our Naman Naitak Sahu. So he is going to do his theory today. So we encourage students to come up with new theories as well. So he is going to present one new theory called Netherite, the my material alloy theory. That's part 2 of it. And he is a grade 5 student from Ekya school BTM, and he is a research member of Aerospace now. Okay, Naman, you can take over now.
Okay, so first things first, since the first part wasn't done in the live stream, we'll also do part 1 in this. It won't take too long. So, Jagu, mash your screen.
Yes, please.
Alright, so I will start with part 1 first of all. Let me just hold on. It was done very long back, I suppose almost a year now. And yeah, I'm gonna start presentation. Hope it's working. Yes. So I'll share screen now. Boom. So this is part 1, and just to be very informative, I don't recommend you thinking about this is about games and everything. This is just top ideas from random things. So I will just see where this did this start from. So yeah, those who have seen my presentation of this earlier know what this is. And um, in this game, there are diamonds. People say it's the best store, or is it? In a 1.16 update, they are in netherite, a material better and more durable than diamond. And this is not about games. I did say this earlier. And I got one question out of this, surprisingly. If diamonds, emeralds, iron, and coal in real life and is in this game, why not netherite? So I researched a bit and found a video which is basically a replica of my theory. Netherite free. Now to get a netherite ingot in this game, you need 4 netherite scraps and 4 gold ingots. So netherite might be a gold alloy, right? So for anyone who doesn't know what's an alloy is a combination of two metallic elements, mainly purposeful to make it stronger and more durable. So there are like more gold alloys: copper, silver, palladium, platinum, zinc, nickel, etc. Okay. So what could be used to make netherite? In this game, nothing can be burnt but netherite. It is basically resistant to lava. Before I say anything else, let me show you the statistics in the game. It has extremely high burning point because it's resistant to lava, makes sense. Very durable, it is super strong. A gold alloy and pretty expensive. $550,000 for only one ingot, it was calculated. Rarity is extreme and weighs 27.5 pounds per ingot. Now it's even more. So according to me, platinum is the gold alloy with the highest burning point. So I'm gonna just put this in comparison. All the all the gold alloys that I stated, they have a burning point. Anything has a burning point. So nickel, iron, platinum, and palladium. These 4 gold alloys have a higher melting point or burning point than lava itself. Average burning point or the temperature of lava is 2200 degrees. But these have a higher. Let's say platinum is 3200 degrees. Palladium, nickel, and iron both have around 2,800. So, so in durability or rarity, let's consider this first, rarity. Nickel and iron both are the fifth and fourth most common elements on Earth, respectively. So the only two competitors left are platinum and palladium. So now in rarity, palladium is slightly rarer. No, I'm not kidding. Not slightly rarer. It's very rare. More rare than platinum, at least 15 times. So palladium is rare. But what comes in is platinum is slightly stronger than palladium in terms of durability. Platinum is the winner. And in heat resistance, you know the answer, platinum, 3200 degrees, while palladium, 2800. Even though they're resistant to lava, platinum is the winner. So most likely, platinum is netherite scrap. So I would say that netherite is an alloy of platinum and gold. So more about netherite. I wanted to show you some proof because some might disagree. No, this is not real. Material scientists at Sandia National Laboratories have engineered a platinum gold alloy believed to be the most wear resistant metal in the world. It's 100 times more durable than high strength steel, making it the first alloy in the same class as diamond and sapphire, nature's most wear resistant material. Now that info is more proof to show that netherite might be a platinum gold alloy. When you divide a netherite ingot, it's 13.75 pounds of platinum and gold, which is $175,700 of platinum and $378,700 for gold. But now it's even increased. You need more of platinum and gold to create a netherite ingot. So I will just skip this. I will move on to part 2. Okay, hold, be ready. Because I'm gonna be talking about how we could use netherite. Now that we know it is very durable, very heat resistant, and is pretty rare, we can conclude and see how it could be useful. So rules while I present. I'm not going to say this at all. Now how could we use netherite? Netherite, considerably a platinum gold alloy, is super strong and resistant to lava. So, could we use it to mine very deep, possibly under lava? Maybe. Yeah. We could go under the volcanoes to look for minerals. We could go under the mantle to mine by ourselves. We don't need anything. No AI, nothing. We could just use simple netherite. We could be able to mine possibly under bedrock. Now, if you don't know, bedrock is the lowest layer in the soil and it is extremely hard to penetrate. So, with netherite tools, it might be possible to penetrate bedrock, even though you can't do so in Minecraft. It might be possible. Netherite could be used as a powerful weapon in military combat. What other purposes could be there for netherite? I would like the audience to share your responses.
If you're okay, I can allow them to unmute themselves. Naman, they can't
you can
unmute
allow
themselves
them.
now.
You can allow them to go.
Okay. Yes. Participant now can interact with Naman. Yes, Anish.
So the question is, again, I'm repeating. The question is, what other purposes could be there for netherite apart from what I just spoke? Mining under lava, mining below bedrock, and military combat. Any others?
Application.
Like,
like what to say, like for building space stuff, like
Nice.
the space elevator, like
Could be. Yeah,
Yeah.
possibly.
But cost is little high, but fine. Space applications we can consider.
Yes.
Okay. Others? Suggest some applications for this alloy.
Like we'll stop sharing for a couple seconds, okay?
Yeah, yeah.
Okay. You can share your responses.
Okay.
Could even try to use evidence. That's why I stopped sharing screen. You could use evidence, no problem.
Yeah. So who wants to like come up with some unique applications? There are a lot of applications. We even had a sessions on alloy.
Yes, Jago. We had.
Like in Meghnad's story, we had actually, yeah, Brahma comes and teaches something.
and you said one thing in Alloy, what you will do in the future, you said, I said for that, for Alloy, I make a shoot something for military that when they will shoot by a gun, like a bullet shoot, it will not be heavy. Bullet shoot will be heavy.
Bulletproof.
It will be weightless. Like that, I will make me great. I said, you remember, sir?
Yeah. That you can tell alloy this application for this as well.
Yes.
Okay, anyone else? I can see a lot of in the chat box.
Yeah, Jago.
To make rockets which can go near the sun.
Yes. But the temperature of the sun is a matter of fact.
More than 6,000 degrees. No?
Yes. Maybe netherite could, but it won't last so long.
Yeah. So one of the students, he came up with this brilliant idea of using healing. There are materials which can heal.
Yes,
Like
Wolverine
this.
material.
Yeah, that kind of material. But actually those kind of material exist, but they take some time to heal.
Yeah, they're pretty expensive.
Some textile engineer, I was discussing this with one textile engineer who had done a PhD. So she was telling there are actually materials which heal.
Yes,
So
they regenerate by
possible.
themselves.
Then Ria, we can use to dig up to the core of Earth. Yeah, that is
Yeah, that could actually be possible
possible.
since
100%
the
possible.
Earth's core is nearly as hot as the sun. It could be possible.
You got that to
If we
power a
could
beacon.
modify netherite to be more heat resistant, that would be possible.
Yeah. What is power a beacon? You cover that to power a beacon.
Oh, beacons. Beacons are not so realistic, right? They're in Minecraft, but like beacons in real life, like imagine just a beacon that could allow you could literally have superpowers like speed, strength, resistance, everything. Only in the games nowadays. Beacons are fictional, but netherite may not be fictional. It could be possible to be developed.
And the digging the earth is one of the ideas. Nice idea. Because we haven't explored more than 11 kilometers under Earth.
Yes, Jago.
We explored whole solar system, but there is no one to explore the under Earth. And there are theories
Yes.
which talk about hollow Earth theory.
And now we have asteroid mining and everything, but nobody could penetrate bedrock and go below the core.
Yeah. And
At
then I
least
used to
mine
read
below
about this.
bedrock before thinking about mining asteroids.
And I was reading about this 10 avatars of Vishnu. The 10th avatar actually has some connection with this hollow Earth, Agartha and Sampala. These are the physics
Extraterrestrials.
are yes, Vishnu,
Extraterrestrials.
extraterrestrials, yeah. And the mention about this available in the Tibetan
You would even search in Google about netherite and the same like article would pop up that in the thing, right? Where they found a platinum gold or like 100 times stronger than
SJ are saying something. Netherite is a Minecraft. Is it exist in real life?
it could. I mean, it could. It's an ore. It could be possibly made
Okay.
because we know what most likely are the ingredients to create it. So we could possibly create it.
Nice. So yeah, so we can continue.
Okay, let's continue. If there are no other ideas, then I will continue.
Yeah. So anyway, they'll be typing in chat box.
Yeah. Okay. So, wait, I'll just share screen. So, netherite in space. Anish said correctly, we could use it for space. Many others did too. Since netherite is extremely durable and nearly invulnerable, we could use it for space, crafts, and astronaut suits, right? Well, yeah, yes. Though netherite is strong, it isn't so heavy. It is like one of those materials that is super strong, but it doesn't have hardly any weight. Since it needs 4 platinum and 4 gold ingots. That means it weighs around 40 pounds. An average human weighs 4 times more than that. You could actually handle that weight. We could use it for suits minimally to increase durability, but not so much, or else there'll be a lot of pressure on the wearer of the astronaut. So I would like to show a video which I did say in the last part was a replica, and yeah, I would show it. Okay. Sorry for the lag.
Netherite, the strongest material in Minecraft. It's not actually a metal in real life though, right? Or is it? Surely this neglected notion that this new netherite material might be a real life mineral could be true, right? There might not actually be a metal called netherite, but could there actually be evidence of this being a real life metal? And I even searched the entire internet, and I couldn't find a single answer. A single answer. Well, I did find something on Reddit, actually, but it's clearly a joke. And could we actually be able to buy this? Well, that's what we're finding out today. First, let's take a look at the netherite crafting recipe. As you can see, it's 50% gold. It's also 50% netherite scrap. So we can conclude that netherite is 12k gold. We know this because 12 karat gold contains 50% gold and 50% alloys. This perfectly describes the netherite crafting recipe. So we know that netherite is an alloy, a metal made by combining 2 or more metallic elements, especially to give greater strength or resistance to corrosion. So we can conclude that netherite is an alloy. So the real question is, what is a netherite scrap? So the obvious solution here is to compare the properties of netherite to the properties of other metals, then whichever is the closest is most likely netherite scrap. We know that netherite scrap must have a very high melting point. We know this because netherite is the only material in Minecraft that actually cannot burn. We know that netherite is also very dense and tough. This is because it has the highest durability and it's the strongest weapon and armor. We also know that it must be pretty malleable, which basically means it can be molded without breaking or cracking. There has to be some way for netherite to be molded around diamond, right? It has to be able to be combined with gold. and it must be extremely rare. In fact, it's the most rarest ore in Minecraft. So now we know about the properties of netherite, which can help determine what metal is it. But where do we start? I mean, there are literally thousands of minerals. Thousands of minerals. Like, where are we gonna start? How are we gonna use process of elimination to determine which one is it? Well, remember in the beginning of the video how I said that netherite is a gold alloy? And some common gold alloys are zinc, copper, nickel, iron, cadmium, aluminum, silver, platinum, and palladium. I'm aware there could even be more candidates to what could be netherite, and I even thought tungsten could be one, but stick with me here for a second. It'll all add up later. So whichever metal has the properties closest to netherite must be the imposter, is the netherite scrap. Let's first measure their melting temperature. The average temperature for lava is 2,200 degrees Fahrenheit. So if the metal's temperature is less than 2,200 degrees, they'll be kicked out. Using this logic, we can confirm that cadmium is out at 609 degrees Fahrenheit, zinc is out at 787 degrees Fahrenheit, aluminium is out at 1,221 degrees Fahrenheit, silver is out at 1,763 degrees Fahrenheit, and copper is out at 1,984 degrees Fahrenheit. Sorry copper, but you were pretty sus. We've now eliminated some of our potential candidates. It's getting really close. I wonder what it'll be. So nickel's safe at 2,651 degrees Fahrenheit, iron at 2,800 degrees Fahrenheit, platinum at 3,215 degrees Fahrenheit, palladium at 2,831 degrees Fahrenheit. Next, let's judge how rare they are. Nickel is out being the 5th most common element, and iron is out at being the 4th most common element. Platinum and palladium are our final contestant. So, our final two, platinum and palladium. So which one is it, you might ask? Let's first judge their rarity. They're both pretty rare metals, but palladium is one of the rarest metals on Earth, and even more scarce than platinum. So, palladium wins the first round in rarity. Round 2. Let's next judge them by their strength. So in this department, platinum is slightly stronger than palladium. So platinum wins this round in terms of strength. So now, the final variable. Let's next measure their heat resistance. Is the winner gonna be platinum, or is it gonna be palladium? Leave your theories in the comments down below. Where I said that platinum has a higher melting point than palladium. So platinum must be netherite. But hang on, I know you want to know the price of this thing, so you could buy it too. I know my claims that platinum is netherite scrap seems absurd and non-evidence based, and I wasn't 100% sure too until I saw this. Platinum meets all the requirements. It's dense and malleable, and it's one of the most rarest metals on Earth. If we analyze the periodic table, we can see that platinum and gold are right next to each other. It's even found near gold and diamonds, which are the ingredients needed to make netherite equipment. Now, while doing the research for this video, I found a very interesting article, one which definitely proved that netherite is platinum.
Grammarly does more than catch errors. With Grammarly, you can find really good,
Made up of a combination of platinum and gold, the new material is apparently 100 times more wear resistant than high strength steel, which makes it the first metal alloy to be in the same class as diamond. End quote. So we now know that netherite is a platinum gold alloy. one that's even stronger than diamond. Now, let's determine the price. A typical netherite ingot is 27.5 pounds. So if we divide that by half, we need to find the price of both of them. Typically, a gold ingot of 13.75 pounds is about $378,300. On average, the price of platinum at 13.75 pounds is about $175,700. If you want to, pause the video and try to guess what is up. The price of netherite is $554,000. Remember how I said you could buy it? Well, probably not, unless you're like a millionaire or something. So yeah, sorry viewers. Wait, before you click off, what if I told you that there's actually evidence that netherite was used in Piglin society? Now, you might think I'm crazy, but hold on, see what I mean. This could even explain the mysterious Piglin. But anyways, they probably saw all the gold and jewels. I'm planning on...
Okay. So, that's the end. Thank you. Doubts? Please do share your feedback and suggestions. Thank you.
Okay. So we have quiz near pod.
No, it's a theory, Jagu.
Okay. Okay. So if you have any doubts regarding alloys or netherites, you can ask Aman. So check. So ask any doubts related to alloys. Maybe you can ask few questions. Let's see if we have any basic questions like what is alloy? Who can give what is alloy? Who can tell?
Alloy, yeah. Alloy is a combination of two metals or two non-metals, or between a metal and a non-metal. So they will be like heated and mixed together, or they'll be cooled and mixed together in any ratio.
Okay, Ria.
Same answer, sir.
Okay. So anything related to new materials like netherite, or we discussed some of the super alloys like inconel or some space application alloys. So if you have anything to say about alloys, you can tell. Nice. So hopefully I think all of you got an idea about alloys and especially a new material, netherites. And so learning alloys is one advanced level technology. Whatever we use in our home is most of it is alloy. That can be a steel, mild steel, or stainless steel, the cooking vessels or the ornaments you wear, the gold are all like not the purest form. There will be some amount of copper or some alloy, some elements will be mixed to so that it's easy to do it as a ஒரு ஆர்னமெண்டா கன்வெர்ட் பண்றதுக்கு வந்து யூஸ்ஃபுல்லா இருக்கும். Yeah, so alloys, the knowledge related to alloy is very important, and especially for space related applications, very important. Done. So well done, Naman. That's a nice topic to discuss, and I expect more new topics related to alloys in future, but that's about future.
Yeah, Jagu.
Nice. Thank you, Naman. Well done. I loved the presentation, and it's a very new topic as well. It's the first time someone is presenting related to alloys, and it's very good. Okay, well done. Let's give a huge round of applause for Naman. All of you go on mute.
Thank you, everyone.
Okay, nice. Thank you. Next, let me welcome our presenter, R. Harini. So, to introduce Harini, She is, as I said, she is one of the selected students of out of say almost 1,000 students. She is from Isha Vidya Matriculation Higher Secondary School, Villupuram, and she is from grade 9, and she is going to present on the topic types of planets and its stars. Okay, types of stars and its planets, or planets and its stars. Okay, Aishwarya, I want to know more about this topic. Let's start. So Aishwarya, you can unmute yourself. You can, yeah, you can unmute. Aishwarya, are you there? Hello.
Yes, Jaku.
Okay. என்ன ரெண்டு ஐஸ்வர்யா இருக்கு எந்த ஐஸ்வர்யா தெரியலையே
ஒரு ஐஸ்வர்யா தான்.
ஒரு ஐஸ்வர்யா தானா ஓகே ஐஸ்வர்யால ஹரிணிடா
ஓகே டாகு.
வேர் இஸ் ஹரிணி
ஹரிணியா ஹரிணி இருக்காங்க.
This is one Harini. There's now one more Harini who is supposed to present now. Okay, maybe till she joins back, we wait for 1 or 2 minutes, or Vishnoo can do it. Okay, Vishnoo ready dana? Engada Vishnoo irukka. Yeah. Peace. So, okay. Oh, even Aishwarya pin பண்ணிட்டேனா? Okay. Where is Harini? Harini, try messaging her, no? So, what number irukka? You have a number, Harini?
Namaskaram Jaku, sorry for late.
வந்துட்டாங்களா? யார் வந்தா?
இல்ல இல்ல சட்டிக்கு
Okay, fine. Okay, there is one boy who is like spamming the chat box. Kindly subscribe to his channel. Vignesh, put your channel link in the YouTube live.
Yeah, Jaku.
I'm here.
Sir, now only he did it.
No, அதுக்கு முன்னாடி பார் it has some 15.
I subscribe both channels.
Yeah. Okay.
நீங்க ஆட் பண்ணிட்டீங்க உங்க சேனல்ல.
Okay, to introduce Vishnoo. Vishnoo is presenting his 41st and 42nd theory. இல்ல 40th and 41st theory. 40th and 41st theory, and all are his own theories. So I see one little Einstein, little Newton, little Hawkins, all inside this small boy's brain, which is capable of creating almost 40 theories, and all are like he will convince you with this theory. That's so he come up with a new idea. He was able to someone is talking in the background. Yeah, okay, so he can able to answer all your doubts. He can able to say how to visualize it, how to, you will see now. Okay, so I am amazed with all his theories, and he is from Sri Vageesha Vidhyashram Trichy, to be precise, in Srirangam, and he is going to present his 40th and 41st theory, the climate theories. Yes, Vishnoo, you can start. What happened? You want to unmute one? Unmute.
Jaku, yesterday
sir.
try like a wallpaper classroom.
Yeah, but it's not visible in the live. It's not.
Sir, can you hear me?
Yes. Yes, we can hear you.
Okay. Before going to the presentation, I need to ask you questions for you guys.
Okay, so there are some questions from Vishnu. Yes, Vishnu.
What are the gases are residing in Uranus?
What are the gases inside Uranus?
PhD
Yeah, tell me.
The
Who can
most
answer?
is hydrogen and helium.
and
Hydrogen and helium.
3 gases are main in there.
Okay, 3 gases mainly. Hydrogen, helium. Where என்ன சொன்னாங்க?
That is the solution.
Okay.
Okay. So Uranus is rich in hydrogen, helium, and methane. So how to convert Uranus as a new Earth or a new blue planet or an habitable planet, like that you can say. So can you see the screen?
Yes.
Okay, and this theory is U blue planet theory. U is Uranus. So Uranus blue planet theory. This is my 40th theory. And let's see what we are going to do. So the Uranus is rich in Uranus is the seventh planet of our solar system. All know this. It is rich in hydrogen, helium, methane. Some of them know. But how to change it as an Earth? This is the question. The last line is your question. But how we can change Uranus as a new Earth for all you guys? Sir, you can unmute us.
Yes. ஏதாவது சொன்னியா?
Yes, sir. Doubt getting. Yeah.
உன் வாய்ஸ் ஸ்லோவா இருக்குடா.
Yes, sir.
Ah.
So now.
Yeah, now it's louder.
Okay, then how we can change Uranus as an Earth?
Okay, who can answer? How we can change Uranus as Earth? Audience, kindly give inputs. Dakshan,
Maybe,
tell.
yeah. Okay. So first thing, we have to reduce. Sorry, we have to increase its temperature. Uranus has an extreme temperature, so it's like first thing what we have to do. Plants cannot survive over there. The basic needs we can't have. First thing what you're gonna do is we're gonna modify the humans to make them go there and survive at least for a few days. Then we have to start increasing the temperature of Uranus. And please don't ask me how. So then what it will be like at least we need 0 degrees. It's like minus what minimum I'm saying about minimum minus 100 degrees. That have to increase it by 100 degrees to make it 0. Then after a few years things will go on and the temperature will be the ice will form into water. And the main problem in Uranus is it's full of ice, so there won't be much land to survive on. Then that way, I think we can create an Earth full of water.
Not only water, we need to also. In that way, how we can do it?
What is it? I didn't get you. I didn't get you. Can you please repeat?
Not only water, also land. Also with land.
Yeah, that's the problem. Because Uranus, if we heat it, it will completely be a water planet. Something like we saw in that, the Interstellar movie. That's what will happen.
Okay, my doubt is is methane is injurious to our health or good for our health?
It's completely injurious for our health. If
Okay.
it will, it's like tobacco.
Okay, then how we can survive in it? If
Genetically modified humans. I think I made a presentation on this. Neptune and Uranus colonization. Dinococcus radiodurans. It's a bacteria. Or what is it? What's the name? Tardigrade. You can use any one of them to genetically modify humans. That's what my idea is.
okay, then what about hydrogen and helium?
Hydrogen and helium, I don't think they're going to be a problem because they're everywhere around us.
Okay,
Okay, thank you so much. Thank you.
come. So
You
Uranus
want
is
to give suggestions? Like, how will you convert Uranus, like Earth, like a planet? It's like planet. Yes, Trichy. Oh, okay. I thought you. Okay. Who wants to give their suggestions? Harijit? Vignesh? Yuga?
Jagu, I have one suggestion on this universe theory. Okay.
Not universe theory.
No,
You're
how?
asking how we will convert Uranus in like a Earth like planet.
It's impossible, Vishnu. Obviously, you are just imagining that. I think it's impossible because see, Uranus is fully covered with like water. So for Earth, we need little bit of land. How we can make that? We need to use some material like hydrochloric. So it's impossible to make. We are not God. Okay, we are just a human, so we cannot do. That's impossible.
we can. That's what this thing is about. 1 minute.
Yeah, we can, I'm sure.
Okay.
Vishnoo, you can continue.
Okay, sir. So hydrogen. Hydrogen can be stored and made as fuel. Okay. Not only fuel, fertilizers. In that way, we can use hydrogen. And nitrogen. We need to produce nitrogen for gravity. Helium. In helium particles, we need to produce oxygen, O2. Cause so it will become as heliox. Heliox. If you go in heliox, surf about the heliox in Google, it is the most. It is the most valuable for breathing for us rather than oxygen.
Okay,
It's
Vishnoo,
more.
Hadrit has some suggestion.
Okay,
Yes,
okay.
Hadrit.
Jagu, actually, after, sir, can I say about the colonization, sir? Through Russian's method, that we would make all the ice turn into water. It would be a huge water planet only, sir. We can create artificial islands on it, like how China is creating in South China Sea.
What?
Sir, if we melt all the ice in that Uranus, sir, it would be full of water planet only, sir.
Okay.
And there will be very little land. But we can create artificial islands like how China does in the South China Sea. And we can colonize that Neptune, not Neptune, sir, Uranus.
Hey, do you know about how our planet or how Earth's land is consist of? What does Earth's land consist of?
Okay.
It's an
That
alloy.
land is made of what elements?
Alloy.
The soil, the plants in the
Chemical elements. Not soil, that not like that. Chemically.
Chemically, I don't know.
Okay. It's silica aluminum.
Oh,
Our land is silica aluminum. Okay. Helium. 1 minute. Helium. In helium particles, we need to produce oxygen in it. As it becomes heliox, heliox is more than enough than oxygen, because heliox is more and more than oxygen. We can survive in it. It's not harmful for our respiration. So heliox is better than oxygen. So we can breathe and we can survive in this. So heliox, a gas which is more than oxygen to breathe. So hydrogen is converted as fuel, fertilizer. In our way, He. He means helium, O2 is oxygen. So helium plus oxygen, HiO2, which is heliox. So we can breathe by heliox, not with oxygen. So at last, methane. Methane can be turned as oxygen because it's, as Rakshan said, methane is injurious and harmful for our health. So we need to produce a microbe or a bacteria called oxyphera, which that bacteria will absorb methane, and instead of that, it will leave oxygen. So at the time, we can use helium, heliox, and oxygen at the time. Okay. So if there are any lacks on heliox, we can use oxygen, or if there are any lacks of oxygen, we can use heliox. So oxyphera absorbs nitrogen and release oxygen. So by this, oxygen can be used, and the oxygen itself, oxygen contains some heat. So in that way, the ice gonna melt. It will melt. So the Uranus, which is full of hydrogen, helium, methane, became fuel, heliox, and oxyphera. With the help of oxyphera, it became oxygen. So oxygen contains heat. So the ice become melted. So this Uranus will become like this. So this dark blue, this Uranus right side, this will become this is full of water. So how to put a land, or how to make land on it? As I said, full of water is with silica magnesium. As land is silica aluminum. Now we are living in Earth now, and this Earth in land contains of silica aluminum, and our ocean contains of silica magnesium. So if we prepare a silica aluminum and spread it on Earth, spread it on Uranus, uh, we can use silica aluminum and put it on there. So Uranus has gotten ready as U blue planet. Is there any doubts? That's it.
No doubt. It's amazing presentation, Anna.
no doubt, Anna.
Okay, அது ஒரு வாட்டி அப்படியே தமிழ்லயே
For the first time ever, I've seen Vishnoo's presentation without even a single doubt, or without less than at least 5 doubts.
இப்பதானே சொல்லியிருக்கேன்.
இல்ல டக்குன்னு நோ டவுட் சொல்லிட்டாங்களே, அதனால தான் கேட்டேன். ஏன்னா every time he comes in, there will be at least there'll be a single controversy. That's the thing.
With Yuga and me.
யுகா தான் இருக்கானே எங்கடா யுகா?
அதிசயமா இருக்கு சார், டவுட்டே கேட்காம.
யுகா எங்க இருக்கானே? உன்னை பற்றி தான் பெருமையாக சொல்லிக் கொண்டிருக்கேன். சரி, அது ஒரு வாட்டி தமிழ்ல ஒரு வாட்டி எக்ஸ்பிளைன் பண்ணிடும்.
ஓகே சார்.
இது அப்படின்ட்டு டூ பார்ட்டிசிபென்ட் ரெஜிஸ்டாங்க. சொல்லுங்க. அத்ரத், எஸ் அத்ரத்.
sir. I forgot to lower my hand.
Yes.
That's all.
Immersive view is not visible in live.
Yeah, Jaku, it's not visible in a live.
Which is not visible? Immersive view.
Immersive.
I didn't see the.
It is. I saw this thing.
I saw the live, it's not working.
Okay, that's fine.
Yeah, me too. It's not working.
Katri, yes, you want to share something related to the theory, Vishnoo's theory?
So that time I said, sir, actually, we can also, after the Uranus would be full of water if we melt all the ice, and there would be very little land, and we can create artificial islands by creating artificial islands in the Uranus, that water place, and we can make people live there.
ஏதோ சொன்னேன் ஒண்ணும் புரியல. ஓகே,
கேன் யூ டைப் இட்? ஏன்னா புதுசா ஐடியா சொல்லும்போது நம்ம அதுல இருந்தே இன்னொரு யோசிக்கலாம்.
yeah, so yeah, Andrit is actually giving his idea. So he is telling how to create I think oxygen and make life to survive. நீ வாட்டி அப்படியே தமிழ்ல எக்ஸ்பிளைன் பண்ணிடு அந்த தியரி.
ஓகே சார். சார் உங்களுக்கு புரிஞ்சுதா சார்?
எனக்கு குழம்பிடுச்சு. Because you said helium oxide, no, I'm thinking what is helium oxide?
Sir, not helium oxide, it's heliox.
Helion. ஆமா அதான் அந்த heliox. அந்த heliox சொன்னதுக்கு அப்புறம் I'm thinking what is heliox? அதுக்குள்ள
பார்த்தா கூகுள்ல சர்ச் பண்ணி பாருங்க. ஆர்டிஃபிஷியலா செஞ்சது.
That's what. Because I used to make this funny game by make people to breathe helium and they talking voice.
Yeah.
There no need of that.
So your voices will change if we go to Uranus with heliox, no?
Maybe.
Definitely. So it will be funny. People will be talking. So fine. மறுபடியும் அவர்கிட்ட எக்ஸ்பிளைன் பண்ணிடு so that it will be clear.
கமெண்ட் தானே சார்?
எஸ்.
ஓகே. யூ ப்ளூ பிளானட் தியரிங்கிறது வந்து உரேனஸ் 7th பிளானட் ஆஃப் அவர் சோலார் சிஸ்டம். இது வந்து ஹைட்ரஜன், ஹீலியம், மீத்தேன் இதெல்லாம் விட்டுருங்க. அடுத்து ஹைட்ரஜன். இது வந்து ஹைட்ரஜனை நம்ம எது வேணாலும் யூஸ் பண்ணிக்கலாம். அதை கம்ப்ரஸ் பண்ணி ஃபெர்டிலைசரா இல்லை நம்மளோட யூஸுக்கு ஹைட்ரஜனை ஃபியூயலை கூட மாற்றிக்கலாம். ஹைட்ரஜன் இந்த பிரச்சனையும் இல்லை. அதுக்காக எல்லா கேஸையும் எடுத்து இந்த மாதிரி கம்ப்ரஸ் பண்ணி ஃபியூயலெல்லாம் பண்ணினோம்னா நம்ம வாழ்றதுக்கு இடம் இருக்காது. ஸோ இந்த மாதிரி ஆயிரும். ஸோ சாரி, ஹைட்ரஜனுக்கு HCI வரும். ஸோ இப்போ ஸ்பெல்லிங் மிஸ்டேக்ஸ் அடிக்கடி வருது சார். அதான் ஹைட்ரஜன் இது வந்து ஸ்டர் பண்ணி ஃபியூயலா பண்ணிடலாம். நைட்ரஜனை வந்து ப்ரொடியூஸ் பண்ணி கிராவிட்டிக்கு யூஸ் பண்ணிக்கலாம். ஓகே சார். நைட்ரஜனை யூஸ் பண்ணி நம்ம கிராவிட்டி யூஸ் பண்ணிக்கலாம். நைட்ரஜனுங்கிறதே கிராவிட்டிக்கு தான். அப்புறம் ஹீலியம் வந்து ஹீலியம்குள்ள ஆக்சிஜனை ப்ரொடியூஸ் பண்ணி ஹீலியாக்ஸா மாறிடும். அதாவது ஹீலியம் பிளஸ் ஆக்சிஜன் ஹீலியாக்ஸ். ஸோ ஹீலியாக்ஸை வச்சு நம்ம ப்ரீத் பண்ணலாம். அதுல எந்த பிரச்சனையுமே இல்லை. அதை வச்சு ப்ரீத் பண்ணி அதுலேயே நம்ம சர்வை கூட பண்ணலாம். ஸோ நெக்ஸ்ட்டு இது மீத்தேன். மீத்தேன் வந்து ஆக்சிஃபெராங்கிற ஒரு இது இருக்கு. ஆக்சிஃபெராங்கிற ஒரு பாக்டீரியா. அந்த ஆக்சிஃபெரா வந்து அதை வந்து மீத்தேனை அப்சர்வ் பண்ணி எக்ஸ்சேஞ்ச் ஆஃபர் மாதிரி மீத்தேனை உள்ள எடுத்துட்டு ஆக்சிஜனை வெளியே விடும். அதனாலதான் ஆக்சிஃபெரா. அது வந்து அதான் மீத்தேனை அப்சர்வ் பண்ணி ஆக்சிஜனை வெளில விடுங்கிறப்ப அது நமக்கு யூஸ்ஃபுல் தான். ஸோ ஃபர்ஸ்ட் நம்ம ஆக்சிஜனை சர்வே பண்ணிட்டு இப்போ ஆக்சிஜன் வந்து தட்டுப்பாடு ஏதாவது வர முடியல அப்படின்னா அப்போ ஹீலியாக்ஸ் வேணா யூஸ் பண்ணிக்கலாம். ஸோ இந்த மாதிரி விஷயத்துல ஹீலியாக்ஸ் தான் நிறையா இருக்கும் ஆக்சிஜனை விட. ஸோ ஃபர்ஸ்டே ஹீலியாக்ஸ் பண்ணலாங்கிறது என்னோட. ஸோ அப்புறம்
Anish has a doubt. Is oxifera real?
Yep.
என்ன
ஆக்சிஃபெரா, ஹீலியாக்ஸ் இதெல்லாம் ஆர்டிஃபிஷியலி மேடு.
ஓகே. Nice.
எல்லாம் விக்கிபீடியால சர்ச் பண்ணி
ஆக்சிபரானா
மண்டை
எதாவது மிக்ஸ் பண்ணுவாங்க?
ஆக்சிபராங்கிறது அதான் சார் பிரீத்திங். அதாவது மீத்தேன் அப்சர்வ் பண்ணி ஆக்சிஜனை வெளியே விடுறது தான் ஆக்சிபரா.
ஓகே.
ரக்ஷன் டார்டிகிரேடுன்னு சொன்னதை நான் அப்படியே மாத்தி ஆக்சிபரான்னு போட்டேன். அதுக்காக டார்டிகிரேடும் ஆக்சிபரா ஒண்ணும் இல்லை சார், ரெண்டு வேற வேற.
வேற வேற. நைஸ் நைஸ்.
ஸோ அது ஃபுல்லா ஆக்சிஜன் வந்து அது ஒரு ஹீட், அதுக்கும் பர்டிகுலரா எல்லா கேஸுக்குமே ஹீட் இருக்கும், ஆக்சிஜனுக்கு சொல்லவே தேவையில்லை. இப்ப அந்த ஆக்சிஜன் அந்த ஹீட்டால மீத்தேன் எல்லாத்தையும் எடுத்தாச்சு, ஆக்சிஜன் அங்கதான் இருக்கு, ஹீலியாக்ஸ் அங்கதான் இருக்கு அப்படிங்கிறதுனால அந்த ஹீட்டை வச்சு இருக்கிற ஐஸ் எல்லாமே மெல்ட் ஆகி இப்படி இருந்த, அதாவது லைட் ப்ளூ பால் மாதிரி இருந்த ஒரு உரேனஸ் வந்து கிட்டத்தட்ட நம்ம இது மாதிரி ஆயிரும். அதுல இந்த எவாப்ரேஷன்ஸ் இந்த மாதிரிலாம் ஆகும், அதுல எந்த பிரச்சனையுமே கிடையாது. அதுலயே ரெயின்லாம் வரணும், ரெயின் இருக்கணும். ஸோ உரேனஸ் இஸ் ஃபுல் ஆஃப் வாட்டர் ரைட் நவ். ஸோ இப்போ லேண்டுக்கு வந்து இது லேண்டு, நம்ம இருக்கிற லேண்ட் வந்து சிலிக்கா அலுமினியம். இப்போ அதையே நம்ம உருவாக்கி உரேனஸ்ல விட்டு ஸ்ப்ரெட் பண்ண விட்டோம்னா நமக்கு வந்து இது ஒரு ப்ராஃபிட் தான். இதை வச்சு நம்ம லேண்ட்லேயே சர்வே பண்ணிக்கலாம், அண்டர் வாட்டர்லாம் இருக்கணும்னு அவசியம் இல்லை. ஸோ உரேனஸ் வந்து எர்த் மாதிரி ஆயிடுச்சு. தட்ஸ் இட்.
Nice, nice. But again, the problem is it's far away from sun, la. So it'll be very cool.
Yes, sir, but oxygen is there.
So you need to create some artificial sun.
ஆனா ஆக்சிஜன் இருந்தாலும் வந்து
ஆக்சிஜன் இருக்கணும், கார்பன் டை ஆக்சைடு
இருந்தா maybe we can create.
கார்பன் டை ஆக்சைடு இருந்ததுன்னா ட்ரீஸை விட்டு கூட வளர விடலாம். கார்பன் டை ஆக்சைடு நமக்கு வேணும். ஸோ ட்ரீஸ் வந்து கார்பன் டை ஆக்சைடு அப்சர்வ் பண்ணுங்கிறதுனால வந்து கார்பன் டை ஆக்சைடே அங்கே விட்டுறலாம்.
So you have.
No, I have a doubt. How we can make land on Uranus?
அதான் சிலிக்கா அலுமினியம்.
Silica aluminum.
Okay, so how can we design that first of all?
இதெல்லாம் மேக் பண்ண முடியாது.
என்ன இதெல்லாம் பில்டிங்கா டிசைன் பண்ணதுன்னு கேக்குறா?
But இப்போ நம்ம அந்த மெட்டீரியல் யூஸ் பண்ணா கூட how we can build that? We need to have an infrastructure.
வீட்டுக்கு இன்ஃப்ராஸ்ட்ரக்சரா?
Not like that. I'll just explain it to you. This is just the whiteboard, okay? If you take this as the
YouTube.
Sorry, if you take this as the earth, and if you take
earth இவ்வளவு குட்டியா இருக்காது.
Sorry da, இப்படி இருந்துச்சுன்னா how we need to put the land, how we can put that? That's only I'm asking.
அதுக்கு தானடா இவ்ளோ நேரம் காடு மாதிரி.
But you told the material. இப்படி நம்ம டிசைன்
Ria has idea. Yes, Ria. Hello
விக்னேஷ் சார்.
Yes, Vishnoo.
டவுட் கிளியர் பண்ணிடுறேன். இப்ப அலாய்ஸ் இதோ இப்ப நமன் பண்ணானே,
ஆமா,
அலாய்ஸ் அத பத்தி அது என்ன சாலிடா இல்ல லிக்விடா?
சாலிட்.
அதே மாதிரிதான் இந்த அலாயும் ஒரு சாலிட். இதை ஃப்ளோட் பண்ணா எதுவும் பண்ண முடியாது.
பட் எனக்கு என்ன டவுட்னா, எனக்கு நீ சொல்லிட்டு கிளாரிஃபை பண்ணி நான் என்ன கேக்குறேன்னா, இப்போ நீ ஒரு இன்ஃப்ராஸ்ட்ரக்சர் பண்ணுவாங்க. இப்போ எர்த்ல 7 கான்டினென்ட் இருக்குது.
7 கான்டினென்ட் இருக்கு.
அதே மாதிரி இப்படி நீ யுரேனஸ்ல பண்ணுவ, அதுதான் கேக்குறேன்.
அது நமக்கு நம்மளால டிசைன் பண்ண தெரியாதடா.
காலனைஸ் பண்ண முடிவு பண்ணிட்டா we will do anything.
அதான்.
யா பட்
பொண்ணு கேள்வி என்னன்னா வந்து கடல் ஒரு லேண்ட் இருக்குன்னா கடல் இருக்குல்ல, அந்த லேண்ட் வந்து அந்த பர்டிகுலர் ஏரியா அந்த கரெக்டா இருக்கணும் அந்த இடத்துல.
அப்படிதான் இருக்கணும்னு அவசியமே இல்லை. ஏன்னா நம்ம வந்து இங்க இருந்து ஏரோப்ளேன்ல பிடிச்சு இன்னொரு ஊருக்கு போகணுங்கிறது அவசியம் இல்லை. ட்ரெயின்ல இருந்து அங்கே
நீங்க சூப்பர்மேன் ரிட்டர்ன்ஸ் நினைக்கிறேன். they use these crystals to create islands.
நிஜமாலே கிறிஸ்டல்ஸ் வச்சு ஐலண்ட் கிரியேட் பண்ணுவாங்க.
But there is some kind of science behind it. அது பத்தி ஸ்டடி பண்ணனும். You can actually grow crystals. In Anna University there's a separate lab, crystal growth center. Check it.
Okay.
So nice. So Ria shared something in chat box. After producing oxygen, the ice.
கிறிஸ்டல்ங்கிறது என்ன தெரியுமா ஜக்கு? இப்போ ஒரு மெட்டல் இல்லனா ஒரு லிக்விட extreme temperature cool heat பண்ணிட்டு அப்புறம் rapid ஆ cool பண்ணா something that forms is called as a crystal.
Okay.
One more time tell Anna.
See, liquid or metal, okay? So it will be heated extremely to an extreme temperature and it will be rapidly cooled down. So what forms as a residue is a crystal. Got it?
Okay.
Yeah, Anna.
Okay.
Okay. Nice. Okay, Vishnu, நீ அடுத்த தியரி வச்சிருக்கியா?
இருக்கு சார்.
Okay, wait பண்ணு. அதுக்குள்ள நான் வந்து Harini R, if she is okay, she can present. After that, you can do your next theory. Wait பண்ணு. சரியா?
Okay, sir.
Harini, is your network fine now? Can you able to present? Hello. Or you can type it in chat box. Harini R. So she is in from Viluppuram. I guess that area is flooding now with the rains. So I don't know about the network connection. Harini? No, we can't hear you. So you need to fix your mic. Okay, you fix your mic and then come back. So next adukula I'll finish next presentation. So Harini D, are you good to go now?
Yeah, Jagu.
Okay, so we have our new presenter now. That's Harini D. Wait. So Harini D, let me introduce Harini D. She is one of the young, she's one of the students selected from this Isha Vidya group of schools. Out of 10 to, I think 7 to 10 schools, they given us 70 students. So one of the talents they given us. So she's a grade 8 student from Isha Vidya, Ramaniyam, Vanavasi, Salem. And her topic is something very interesting and very new. So the whole world talks about reducing greenhouse effect or reducing pollution, all these things. Or when you talk about colonizing Venus, first thing comes to our mind is get rid of this greenhouse effect or reduce CO2 levels. And Harini has a presentation, artificial trees which can absorb CO2. இனிமே இது தெரிஞ்சா யாராவது மரம் நடுவாங்களா? They will buy all these artificial trees and plant everywhere. But I am curious to know what is this artificial trees. And I never had like we never discussed this topic before. I discussed in one of the sessions, but not with this group. Okay, Harini, you can present. And then
So,
this is
yeah.
the first presentation, first live. Yeah.
So yeah, I'm Harini. So I'm going to present about artificial plant that absorbs CO2. So first I'm just telling about CO2. Carbon dioxide may be a colorless or odorless and completely natural
I
gases.
just see the screen.
You haven't shared your screen, Harini.
So wait.
Artificial trees that can absorb CO2. Everyone.
So can you?
Yes. You can.
Yeah. So first I'm just telling about carbon dioxide. Carbon dioxide may be colorless, odorless, and completely natural gases. But carbon dioxide is beginning to cause us a lot of problems. It only makes up a tiny fraction of atmosphere, 0.04% of all gases by volume, or 395 parts per million. but it's a huge effect on Earth's temperature. That's because unlike nitrogen or oxygen, carbon dioxide molecules absorb the sun's heat rays. Even through they left, light rays passes through like a greenhouse effect.
Okay. You need to unmute yourself. You're muted. Harini, you are in mute. So something your check is.
Yeah. 1 minute.
I don't know.
It is a check. Yeah, I think so. It's some account name.
Yeah, check.
Wait, Shrijith. It's okay, I'll trim it from the live. No issue.
How it's my screen was went. So
No, I just removed the share screen. Now she can share again. That's okay.
Yeah, Jagu.
Jagu, I wanted to ask you. So I wasn't available for the past few weeks. So did it just go like presentations or something else special happened?
Harini, tell me once you are ready. So, Rakshan, yesterday we learned how to access Chandrayaan 2 images.
yes.
Yeah.
Okay, she is starting. Harini, you are in mute.
So 1 minute it's
What happened? I removed the share screen.
yeah. So,
Parala, you share, you just talk. That's fine. If you are unable to share screen, fine, no problem, because all of us can understand the
Jagu, she's not sharing PPT.
It's not PPT, it's an image you are sharing.
Where is PPT?
Yeah, Harini, you can share the PPT in the group. One of us can share it.
Okay.
Ria is in the group, right?
Yeah. Yes.
Yeah, on the group podunga. Naane share pandren. No issue. Just put it in the group.
So scientists are looking up the way to So 1 minute.
Or if you are not sharing the PPT, no issues. You can just talk because most of us are familiar with this topic. They will understand.
Okay. Sir, no problem. Scientists are looking at the ways to modulate the global temperature by removing some of these greenhouse gases from the air. If it works, it could be one of few ways to engineering the simply cooling the atmosphere. Since the industrial revolutions, humans have been burning an increasing amount of fuels, releasing stored carbon of million years ago.
No issues, no issues. Continue. The image is not needed.
Okay. Fuel. So eventually, the atmosphere will reach a new balance as at a hotter temperature as the result of the additional carbon dioxide, but getting there is going to be difficult. So now I'm going to share about artificial plants. So the leaves look like a sheet of papery plastic and are coated with resin that contains sodium carbonate, which full of bicarbonate baking soda on the leaf. To remove the carbon dioxide, the leaf are rinsed in the water vapor and can dry neutrally in the wind, soaking up more carbon dioxide. So,
You
Lantner
have the image, Harini, you have the image of the artificial carbon dioxide plant or material. Can you show it?
Yep.
Sir,
Yes, Vishnoo.
I have already done a PPT.
My voice lower.
I have already done a PPT about how to reduce carbon dioxide, but I
Okay.
haven't presented yet.
Oh, so maybe yeah. See, this is the actual prototype made, the artificial tree, artificial carbon dioxide tree. Even I have seen the whole area is covered with this. So you can now explain the materials, Harini. The baking soda adala sonnalla.
Yeah.
You can use
Sure.
this image to explain. When you are mute.
Yeah, sir. So these leaf-like structures are made up of baking soda. So resin coated. So it was coated by a resin. So which contains carbonate, sodium carbonate. So yeah.
Okay.
To remove it, to remove carbon dioxide which is absorbed by the plant, so we have to rinse in water vapor, so it may be dried easily. It can get dried easily by wind, and yeah, that's it.
Okay.
So Lackner calculates that his trees can remove 1 ton of carbon dioxide a day. 10 million of these trees could remove 3.6 billion tons of carbon dioxide a year.
Repeat it. It can absorb 1 ton of carbon dioxide per day.
Yeah.
And how many trees can remove some 3.6 billion? 2.6 billion.
I didn't catch you.
So you said it can remove some 2.6 billion of something.
Yeah.
What is it? Repeat.
No, 3.6 billion tons of carbon dioxide a year.
Oh, per year it can remove 3.6 billion tons of carbon dioxide.
Yeah.
Okay.
So equivalent to about 10% of our global annual carbon dioxide emission. Our total emission could be removed within 100 billion trees. He says, whereas we would need 1,000 times that in real trees to have the same effect.
Okay. So Vishnu has a doubt. Yes, Vishnu. Doubt or suggestion or input?
It means I am having a doubt with the climate
Volume.
Then I'm having doubt in a climate change. If you observe 3
Too much of
point
carbon
this
dioxide.
blah blah blah
Billion.
billion.
Can you see an image? All these are carbon dioxide trees planted.
Okay, sir.
White color.
Mountains, yeah.
How they can be planted?
They can't plant it. You build it and place it.
Okay, Jago.
How it will carbon dioxide is also needed for climate change, so
yes
we can survive by it now. At least we need a minimum amount of carbon
இதுல ஒரு
dioxide.
அட்வான்டேஜ் இருக்கு. இதுல remove பண்ணுங்கிறது அப்படிங்கிறது it will absorb and keep it within inside. When you want carbon dioxide, when you just soak inside water, all the carbon dioxide will get released.
Yeah, Jagu, இது நான் என்ன நினைச்சேன்னா அது பிளான்ட்னு நினைச்சேன், but it's like instrument. I thought it was plant.
Yes.
எனக்கு ஒரு ஐடியா தோணுச்சு எனக்கு.
Let them complete because there are so many ideas you can discuss this as well. Yes sir.
சார் நிறைய டவுட் இருக்கு போட மாட்டேன்.
முடிச்சிட்டு பேசலாம். Continue. Harini.
Well, that's it.
Okay.
I have finished, but I have a video to show.
Yeah, please.
ஓகே ஜாகு எனக்கு ஒரு ஐடியா தோணுச்சு. அது என்னன்னா
Let her finish showing the video.
Okay.
We can discuss because this is used in, we can be used in Venus colonization. It can be used in
ஜாகு அதான் ஜாகு ஒரு மாஸ் காலனைசேஷன் சொல்றதுதான். நிறைய மாஸ்ல வந்து அதிகமா கார்பன் டை ஆக்சைடு இருக்குல்ல.
Harini, you can share video. We can't see anything.
அதான் என் ஐடியா ஜாகு. அது முன்னாடி நீங்க சொல்லிட்டீங்க.
இதுலயே எனக்கு ஒரு டவுட் இருக்கு.
Harini, video share ஆகல. You need to link now. You put it in chat box. We will share it. Or you can yourself can share it.
Yeah, sir. 1 minute. Yeah, is it visible, sir?
Yeah, visible now. So you need to share audio as well.
Yeah.
Yeah, I cannot hear anything.
Sound share பண்ணுங்க.
BBC one. What is what?
Biosphere 2 in our
First.
dioxide, but they release it during the night and when they decompose. So Professor Klaus Lackner and engineer Alan Wright have been designing a tree which could be more efficient than the real thing. It was here at Biosphere 2 in Arizona that the idea was first conceived. Biosphere 2 was the largest completely airtight artificial ecosystem ever built, the perfect place to study how changes in carbon dioxide would affect the planet. After working on several prototypes, Klaus and Alan now think they might have finally cracked it. This was an early design, more like a cabinet than a tree. Inside, a plastic that absorbs CO2.
These plastics are ion exchange resins, which are commonly used in water preparation. If you desalinate water or make deionized water, this is the kind of stuff you would use. You can buy it commercially in large quantities.
At first, they used chemicals to wash the CO2 out of the plastic so it could be reused. But this needed too much energy to be viable. Then they made a discovery that was quite simple.
Maybe take the bell jar off.
It happened after they'd set up a basic experiment using nothing more than an airtight bell jar hooked up to a carbon dioxide monitor. An experiment they repeated for me.
Here on top you see the plastic material which absorbs the CO2. It has been wrapped in thin strips around the frame.
The level of CO2 in the bell jar starts at 386, today's atmospheric levels. As expected, the plastic immediately absorbs it. So
Yes.
the levels of CO2 in here are really low, round about 140. Okay? But what they do next, they feel is the real breakthrough, and so simple. They dunk the plastic in water.
And we'll just put it back in there. So we close it again. Now the air inside cannot escape.
Back in the bell jar, the wet plastic immediately starts to release the absorbed CO2. Okay, and the levels are already going up.
Yes, so we're going to see it's beginning to trend up, and it will pick up over time as the CO2 is given off by that material.
So, just by making it wet, it's now releasing the CO2 that was previously trapped.
Yes. When it's wet, it doesn't want the CO2, so it pushes it off.
It's as simple as that.
It's as simple as that. It's amazing.
It is. And then you can dry it out again.
And when it dries out again, it will grab more CO2. We'll do this over and over and over and over again. You can literally do this hundreds and hundreds of times.
Having ensured that rainfall will not release the CO2, Alan and Klaus are now building a full-scale artificial tree. When finished, it will have a central drum with panels of the special plastic and a humidity control system. By altering the moisture levels, it will absorb and then release the CO2 for storage. This process requires no chemicals, only a very small amount of energy and a water supply.
The vision of the future for these kind of artificial trees is that they can capture the carbon dioxide nobody else can capture. That's their advantage, that is their strength.
They estimate that a single tree will absorb about a ton of CO2 a day, about 75 cars worth. 60 million trees could potentially absorb all the CO2 we currently emit. And that's not all.
This is one of the few options available to actually go back and reduce the carbon dioxide level in the atmosphere from the level we are already at or will be in 50 years from now, back down to where it is safe.
All this absorbed carbon dioxide would of course need to be put somewhere. But that's where other new technologies come in, like the geological storage of CO2 that's being tested in Utah. And because CO2 levels are the same around the planet, a great forest of artificial trees could be placed right on top of storage sites, so the CO2 wouldn't have to be transported.
Nice. Brilliant. So already video over page 3 nariya per vandittu already they started sharing their feedbacks la, suggestions, ideas. Yes, Shrijith. I'll call out one by one. You can raise your hand.
So my question is that இப்போ ஒரு நாளைக்கு 1 ton மட்டும் தான் வரும், its capacity is 1 ton of carbon dioxide.
That's I think for a smaller unit. You can absorb more as well if the size is bigger.
Yes, sir. So suppose அது அந்த லெவலுக்கு போயிடுச்சுன்னா அங்க பக்கத்துல ஃபேக்டரி இருக்குது. So if the factory produces a lot of CO2 and within half a day the full tree has absorbed its capacity, full capacity. So அதுக்கு மேல எது அப்சார்ப் பண்றதுக்கு சான்சஸ் இருக்குதா?
இருக்காது. You need to either rain வந்துடுச்சுன்னா it will leave all the CO2 or you need to replace the tree. அதை வந்து எடுத்துட்டு போய் சேஃபா ஒரு இடத்துல வந்து ஸ்டோர் பண்ணிடலாம். So whenever we need
this is a disadvantage or an advantage?
If you want to reduce CO2 level, this is advantage. And if you want to increase the CO2 level, that also is advantage.
Sir, instead of absorbing CO2, you can use
our idea solava
you can absorb carbon and the carbon monoxide. Like these are harmful for us, but CO2 is needed
but
for
the levels
for
of
plants.
Carbon monoxide is very less la, compared to CO2.
சார் இப்ப பண்ற பொல்யூஷனுக்குலாம் இதெல்லாம் நிறையவே போயிருக்கு சார்.
அதுதான் நான் சொல்றேன், இங்க இருந்து அப்சார்ப் பண்ணி put those trees in Mars. So temperature rise ஆயிடும். Yes, Shrijith.
அந்த ஐடியா அதான் ஐடியா தான் மாஸ்ல போறதுதான் அது நீங்களே சொல்லிட்டீங்க.
Okay, but Venus has too much this thing. So put the trees inside Venus, then bring those trees, throw in.
Sir, Venus surface temperature itself above 600
அதுதான்டா above 70 kilometers.
Surface temperature அவ்வளோ இருக்குங்கிறப்ப அது அங்க வெச்சா மெல்ட் ஆகாது சார்.
You don't have to put it. You just hang it at 70 kilometers.
Hang it
70 kilometers above the ground of Venus, it's like Earth. சரிங்களா? It's similar to Earth.
As there is no gravity in Venus, we can.
There is gravity. It's almost similar to Earth. You can hang it.
Sir, Hang it means how we can hang means.
ஏதாவது ஹீலியம் பலூன்லாம் வச்சு ஹேங் பண்ணுவோம்.
சார் ஹீலியம் பலூன் வச்சா பறந்து மேல போயிடும் சார்.
அதான்டா 70 kilometersல keep it because the air density is so high. We can build floating cities in Venus. Once you build the floating cities, hang all these carbon dioxide trees to absorb all this CO2. Okay. Then send all these carbon dioxide trees to Mars and raise the carbon dioxide level.
Okay, sir. Good.
இதெல்லாம் சும்மா I'm thinking. Okay, now you can share your ideas.
But it is a super idea.
Your idea is super idea.
Your idea is super.
Yes,
my idea Jagu. I was thinking like இத நம்ம வந்து அந்த யுரேனஸ் சொல்லினால ரொம்ப சுடுது ரொம்ப ஜில்லுன்னு இருக்கு ரொம்ப ஜில்லுன்னு இருக்கு. இத போய் யுரேனஸ்ல தூக்கி போட்டாங்கன்னா இன்னும் சூப்பரா இருக்கும்ல.
Tram, we can increase the CO2 level, no?
Yeah. Mars, Mars is actually the temperature is 25 degrees தான் human earthல இருக்க மாதிரி தான் அங்கேயும். ஆனா யுரேனஸ் அப்படி இல்ல. நெப்டியூன் அது கூட இல்ல.
Very cool.
Yeah, very cool. So அங்க போய் போட்டாங்கன்னா you can it's an easy throw, right?
Correct. And it also has a good gravity level.
Yeah.
Mars has very less gravity. And Mars
is நிறைய பிரச்சனையே இருக்கு. Content.
திரும்ப மார்ஸ் காலனைசேஷன்ல ஆரம்பிக்க வேணாம் ஜெகு.
வேண்டாம். சரி. Next. So anyone else have any other questions or feedbacks for Harini? Harini, you need to start making presentations. So that will be useful for you. It will be easier. PPTs.
I couldn't get you, sir.
PPT. Presentation mari pannitana. You can change the slide next month. Today we used images, I guess.
Yeah.
So images is kind of confusing sometimes, but using PPT will be much more better. But that's other than that, it's nice. You are good enough. Your presentation is nice. Anyone has any other questions related to or any feedbacks related to presentation?
Yeah, amazing presentation.
This
amazing presentation, really nice one.
Jagu, carbon dioxide causes global warming, no? So, like Rakshan side told, if we put it in Uranus, it will heat up and the ice will melt.
But the methane gases come outside.
Vishnoo, methane விட மாட்டேங்கறா.
Uranus ice fullaவே கீழ இருக்குற.
I know it's methane ice. I know
it's like Titan.
Yeah.
Once you cross, I think Jupiter, I think methane becomes like water, I guess.
Yeah. It's like semi-solid and semi-gas.
I'm guessing.
I think there's a name. I forgot it. You know, there is no liquid state. It's like it directly forms into it directly forms gas. No. Wait a minute. I'll Google it. I forgot its name. I once read about it.
Is there
what is it?
No. Okay, right. Let Rakshan complete.
1 minute. I'm just googling.
Next we have Anish. Anish, Shrijith. Then we have Vishnoo.
ஒரே ஐடியா ரெண்டுத்தையும் வேலையை முடிச்சிருக்கலாம் சார். ரெண்டாவது தியரி பிரசன்டேஷன்ஸ்லாம் கம்மி, ஸ்லைட்ஸ் எல்லாம் கம்மி.
பிரசன்டேஷன் கம்மி தான். வர்ற கேள்வி
சார் ஃபர்ஸ்ட் தியரி
it's called as phase transition. I got it again. Yes, phase transition. It's like it's also how can I say it? Sublime objects. It's like it forms directly gas from solids.
Okay.
This is it. I put it to you in chat.
Sublimation.
Yeah. Sublimation. Yeah, I just forgot the word, Jagu.
அதான் கேம்பர் இருக்குல்லடா, சூடம்.
Yeah, sudam. Yeah.
Sudam, andurundai.
Yes, Jagu.
All this form.
And then direct it forms gas, no liquid.
Okay. Nice presentation, Harini. It like triggered a lot of sparks and a lot of minds. So it's a very good topic to discuss. And it's a very first presentation. Let's give a huge round of applause for Harini.
Thank you.
Well done, Harini. You will be added to Young Researchers crew. So you will get to have a lot of more teammates, a lot of people with similar mindset. You will get to find a lot of crazy minds here. Crazy science, crazy minds. Yeah. Okay. Next, let me welcome our next presenter. Who actually, this is Anish Noel. So, few of you might know him who, if you watched our presentations before. That is, and he's also got one very nice topic, killer topic. Today, I'm just amazed with all these topics. The material alloy theory first by Raman, climate theory by Vishnoo, then this artificial trees by Harini. Next, next topic for level, very tanamana topic. That's called space tram. How many of you know what is space tram? This space tram technology can make space travel $50 per travel.
Not even $50.
Less
Not
than
even $50.
and yes, Sorry, let me introduce you first.
Crazy idea, Jagu. Crazy idea.
So that is, so this is Space Tram, and this topic is going to be presented by Anish Noel, and he's a grade 6 student from St. Patrick's High School, ICSE. Let's welcome Anish.
Sir, $50 is 3,709 rupees.
That is all yours.
Or it could be something like lesser than that.
Yeah.
Solar panels, solar panels.
Star Tram.
இது டிசைன்ல போயிட்டு இருக்கா இல்ல வந்துருச்சா ரிசர்ச்ல இருக்கா வந்துருச்சா
They already tested the prototype. In NASA they have tested the prototype.
Yeah, I'll also be presenting about it too.
Nice.
So hi everyone, my name is Anish Noel, and today I'll be presenting about space. Contents for today are non-rocket space launch, what is space tram, and NASA space star tram, and we'll be directly going into types of star tram. So this development of star tram is basically the same, and comparison of other space launch methods with star tram, and the conclusion. So first we'll see about non-rocket launch, space launch. So non-rocket space launch refers to the concepts for launch into space where much of the speed and altitude needed to achieve orbit is provided by a propulsion technique that is not subject to the limits of rocket equation. A number of alternatives to rocket have been proposed. In some systems, such as combination launch system like Skyhook, rocket shed launch, Raccoon, or air launch, a portion of total delta V may be provided either directly or indirectly by using rocket propulsion. As a result, launch costs are a large percentage of cost for space endeavors. If launch can be made cheaper, the total cost of the space mission will be reduced due to the exponential nature of the rocket equation. Providing even a small amount of velocity to LEO by other means has the potential of reducing the cost to get to orbit. Launch cost in hundreds of dollars per kilogram would make possible many proposed large-scale space projects like space colonization,
space-based solar power and terraforming Mars. So in this picture you see like it's like a gun. No. So this is a method of, there are two methods like which they use this tunnel, which today I am presenting space tram, and there's also a method called space gun. So with this tunnel, they will use it, they will launch the spacecraft. So this is like image of how non-rocket space launch methods could be. So now we'll see about space tram. What is a space tram? Space tram is an old concept which proposes a structure of large tunnel or a long tunnel that is hundreds of kilometers or more and established a vacuum zone in the tunnel. The idea was to launch the spaceship with initial speed of several kilometers per second to reach as high altitude as possible. For achieving that kind of speed, a maglev is meant to be used. This concept may have some advantages over regular rockets-based orbital transport, but also serious issues. First of all, tunnel end must be placed at a high altitude, 6 kilometers or more, to decrease air resistance. Second, this kind of skill requires enormous power supply for each launch. Now we will see NASA Stratum. NASA Stratum is a proposed space launch system propelled by maglev. The initial Generation 1 facility would launch cargo launching from a mountain top at an altitude of 3 to 7 local kilometers, that is 9,800 to 23,000 feet, with an like it's an empty ton tube staying at local surface level. It has been claimed that about 150,000 tons could be lifted to orbit annually. More advanced technology would be required for the Generation 2 system for passengers with a long track, instead gradually curving up its end to a thinner edge at 22 kilometers, that is 72,000 feet altitude, supported by magnetic levitation, that is maglev, reducing g-force when each capsule transition from the vacuum tube to the atmosphere. SPESIF 2010 presentation presented that Generation 1 could be completed by the year 2020 or later if funding begins in 2010, and Generation 2 by 2030 or later. Now we will go on to Generation 1. That is, it's a type of Star Trek. Generation 1. The Generation 1 system proposes to accelerate uncrewed craft at 30 G through a 130 kilometer, that is 81 miles long tunnel with a plasma window preventing vacuum loss when exit mechanical shutter is briefly open, evacuated of air with an MHD pump. In the reference design, the exit is on the surface of a mountain peak of 6,000 meters, that is 20,000 feet altitude, where 8.78 kilometers per second launch velocity at a 10-degree angle takes cargo capsules to low Earth orbit (LEO) when combined with a small rocket burn providing 0.63 kilometers per second, 0.39 miles per second for orbital circulation. With a bonus from Earth's rotation, a firing east, the extra speed, well beyond nominal orbital velocity, compensates for losses during ascent, including 0.8 kilometers per second, 0.50 miles per second from atmospheric drag. A 40-ton cargo craft, 2 meter 6 feet 7 inches diameter and 13 meters 43 feet length, would experience briefly the effects of atmospheric passage. With an effective drag coefficient of 0.09, peak slowing from the mountain launch elongated projectile is momentarily to 20 G, but half within the first 4 seconds and continue to decrease as it quickly passes above the bulk of the remaining atmosphere. The tunnel tube for Generation 1 has no superconductors, no cryogenic cooling rations, and none of it is at a higher elevation than the local ground surface, except for the probable use of SMES as the electrical power storage method. Superconducting magnets are only on the moving spacecraft, including current into reality inexpensive aluminium loops on the acceleration tunnel walls, levitating the craft with 10 centimeter clearance, while a second set of aluminium loops on the wall carries an AC current acceleration the craft, a linear synchronized motor. Now let's go on to Generation 2. The Generation 2 system is supposed to be for reusable crewed capsules intended to be low G-force, 2 to 3 G acceleration in the launch tube, and an elevated exit at high altitude, that is 22 kilometers, 14 miles, that peak aerodynamic slowing becomes 1 G. Though NASA's test pilots have handled multiple times those G-forces, the low acceleration is planned to allow eligibility to the broadest spectrum of general public. With such slow acceleration, the Generation 2 system requires 1,000 to 1,500 kilometers, that is 620 to 930 miles length, and area of Antarctic 3 kilometers, that is 9,800 feet above sea level, is one of the sitting options, especially as the ice sheet is viewed as relatively easy to tunnel through. For elevated end portions, the design considers magnetic levitation to be less expensive than alternates for elevating a launch tube of a massive dryer, that is like a tethered balloon or a compressive or an inflated aerospace material megastructures. And a 280 mega ampere current in the ground cables create a magnetic field of 30 Gauss strength at 22 kilometers above sea level, while cables on the elevated final portion of the tube carry 14 mega amperes in the opposite direction, generating a repulsive force of 4 ton per meter. It is claimed that it would keep the 2 ton per meter structure strongly pressing up on its angled tethers, tensile structure on grand scale. An example of neodymium titanium superconductor carrying 2 into 10 to the power of 5 amperes per second per centimeter per second square. The levitated platform would have 7 cables, each 23 centimeter square, that is 3.6 square inches of conductor cross section with including copper stabilizers. Now let's go into generation 1.5, which is a lower velocity option. An alternative, generation 1.5, would launch passenger spacecraft at 4 km per second, 2.5 miles per second, from a mountaintop at around 6,000 meters above sea level, from a 270 kilometers, 170 mile tunnel accelerating at Trichy. Though construction cost would be lower than Generation 2 version, Generation 1.5 would differ from the other StarTime variants by requiring 4 plus km per second to be provided by other means like a rocket propulsion. However, the non-linear nature of rocket equation still makes the payload fraction for such a vehicle significantly greater than that of a conventional rocket unassigned by electromagnetic launch, and a vehicle with high availability weight margin and safety fraction should be far easy to mass produce cheaply or make reusable with rapid turnarounds that current 8 kilometers per second, 5.5 miles per second, that is accurately rockets. Dr. Powell remarks that the present launch vehicles have many complex systems that operate nearly to the failure point with very limited redundancy, with extreme hardware performance related to the weight being a top driver of expense. Alternatively, Generation 1.5 could be combined with another non-rocket space launch system like monumental exchange tether similar to Hashtag concept, which was intended to take a 4 meter per second, 2.5 miles per second vehicle orbit. Because tethers are subject to be highly exponential scaling, such as a tether would be much easier to build using current technologies than one providing full orbital velocity by itself. The launch tunnel length in this proposal could be reduced by accepting correspondingly large forces on passengers. A 50 to 80 kilometers, 31 to 50 miles tunnel would generate forces of 10 15 Gs, which physically fits test pilots have endured successfully in centrifuge test, but a slower acceleration with a longer tunnel would ease passenger requirements and reduce peak power draw, which in turn would decrease power conditions expenses. Now let's go into a comparison of other space launch methods. So I've given some 7 methods. space launch missiles, and its publication year and its payload mass, that is in kilogram. So if you see Tram, it was published in 2001, and its payload mass is 35,000 kilogram. Then we go to Space Gun, that was published in 1965. Not 19, it's 1865, and its payload mass is 450 kilograms. Hashtag 2000, that is 15,000 kilograms. Then Hypersonic Skyhook, that is 1993. It was published on 1993, and its payload mass is 1,500 kilograms. Orbital Ring, publishing year was 1980, and its payload mass is 2 into 10 to the power of 11 kg. Then Launch Loop, which is small, that was published in 1985, and its payload mass is 5,000. Launch Loop Large 2 has all the same things of Launch Loop Small. It was published in 1985, and its payload mass is 5,000 kilogram. Now let's go into conclusion. If humanity is going to have a large-scale presence in Mars, then Tram will be needed to be developed. Conventional rockets can't get much better and are far too costlier, unreliable, and dangerous. The space elevator would require a breakthrough in materials, and collisions with space debris would be a serious problem. Once the Generation 1 and Generation 1.5 systems are developed, the entire solar system will rapidly become within humanity's reach. Thank you.
Good presentation.
Thank you. And we have Chris.
So if you have any doubts, questions related to space tram or magnetic levitation or how it works, all these questions you can ask to Anish. And you can also add new applications. There are a lot of applications which are unexplored.
Yeah. So I think you might have a doubt in the non-rocket space launch. So
maybe we can, Anish, we can do one second part of the same thing, explaining how all this launch happens, because that itself is a huge topic.
Yeah,
we do part
I was planning to do that.
Then super. Okay, let's go to quiz. If you have any doubts, put it in chat box. We can discuss.
1 minute ago.
Because the time is running now. We have 2 more presenters. That's it.
Yeah.
Next.
I'll send the question.
Next is Shrijith.
Oh, life in space.
Okay. On the next Vishnoo where Vishnoo second where
Vishnoo 5th theory get a number when ready for this.
5th theory already document prepare
do you have any doubt?
50 theories. Book title niye solla. Vishnoo. Okay. You can join quiz. Anish, you can share the quiz screen.
Jago, one thing, if somebody has doubt, you just put it in the chat box. Or no one has doubts.
They will have doubts. They will have a lot of application oriented ideas.
Yeah. Jago, can you see my screen?
Yeah, super.
Okay, 9 have joined 10. And somebody has QQ Evian. That must be a YouTuber.
Yeah, maybe. I'll just now share it. Start.
11. Can I start, Jagu?
Yes, please.
I'm joining 1 second. I'm joining.
Okay.
It's okay. I've given plenty of time. You can. Yeah. Wait.
You can read out the
Okay.
question, Anish.
Space Tram is an old concept which proposes a long tunnel of how many kilometers? I'm asking how many kilometers. 200 kilometers and more, 1000 kilometers and more, 100 kilometers and more, and 2000 kilometers per more. Okay. 3, 2, and 1. Everyone finish. Okay. Leaderboard. Aishwarya is leading. 1 minute. Everyone, only one has given the answer correctly. That is Aishwarya, I think so. Yeah, let's go to the next question.
I think a lot of people misunderstood the question, I guess.
Yeah. No, Jagu, they didn't. They answered the question wrong.
Yeah, that's right. They thought.
Space Tram, yeah. Star Tram is a proposed space launch system propelled by. I know everyone will know this. Okay, let me see the leaderboard. It is Vishnoo leading.
Vishnoo, Yuga.
Yeah. Yeah. And everyone has given Maglev, like 4 of them have given Maglev, 1 has given rocket booster, 3 have given propellant, and 4 given space scramjet engine.
The whole idea itself is magnetic levitation.
கண்டிப்பா scramjet engine வரவே வராது. ஏன்னா அது வந்து இந்தியால தான் யூஸ் பண்ணுவாங்க நினைக்கிறேன்.
Okay, 3, 2, 1. Next question. Who proposed Star Tram?
Just spelling correct or you can answer.
Yeah. No, I gave this name somewhere. If you remember, you'll get it. Come on, Ashwin, Dash has finished. Ashwin has finished. Adrit has finished.
Coco even.
Yeah, time's up. Everyone done. Okay, let's see the leaderboard. This Vishnoo leading, Harjit, then yeah. All have given James S. Powell. It is actually James R. Powell. I mentioned it as R.
Okay.
Okay, next question. Full question. What's inside the long tunnel of space tram? Is it a cannon, superconducting magnet, vacuum, or elevator?
இது யாராவது தப்பா சொல்லுங்க. I already told you the whole project is magnetic levitation. So there must be magnets only inside.
No, it's vacuum.
Superconducting magnet then or cold?
No, it's actually magnet. Inside it's fully vacuum. So.
Hey, I typed vacuum only.
Yeah, you type vacuum. So.
Hey,
you might have. You are in first place. You are in first place. Okay, next one. Next one is types of strength. This is a multiple choice question. Like you can choose anything. Don't pick up the wrong one. Okay, all done. Let's see the leaderboard. It is Vishnoo, Harjit, and Yuga. Everyone almost gave the right answer, And except 3, they gave generation 3. Okay, next question. What is the publishing year of hashtag? I mentioned it in the comparison. Remember it and answer. Aishwarya has not answered. Ashwin has not answered. Yeah, everyone done. Let me check the leaderboard. Ashwin has come to 3rd place. Okay, only 3 have answered the correct answer. Last question. Let's go into the last question. What is the payload mass of orbital ring?
I know the answer, but I have typed wrong.
It's okay. Come on. Last 2, 3.
We'll fill in the blank.
One more. One more. Yeah, everyone done. Okay, let's see first the leaderboard. Leaderboard. It is Harjit, Vishnoo. And
Who's first?
First is wait. Harjit,
Hey,
then
Nana.
Vishnoo, then Bhairavi. Next question.
Who? Aha.
Congratulations to Harjit, Vishnoo, and Bhairavi.
Thank you very much.
And this is only
நீ ராங்கா பண்ணி அப்ப நீ எப்படி பண்ணிருப்பாங்க மத்தவங்கலாம் நிறைய மிஸ்டேக்ஸ் பண்ணிருக்காங்க நிறைய பேர். 2 பேர் வந்து ஃபுல்லாவே மிஸ்டேக்ஸ்.
இல்லடா, the questions are confusing.
Yeah.
Minutes short time taken.
Well done போதும். Next presenter கூப்பிடலாம். That's a brilliant presentation, Anish.
Life in space.
Okay, let's give a huge round of applause to Anish before we welcome next presenter.
Why he's just clapping.
Thank you. Next, we have our one-star presenter from Space Wanderers Company. So that's a long time no see from Space Wanderers. So let me introduce Shrijith Niranjan S. And he is from Treamis International School, research scientist of Space Wanderers Group. And he is grade 6 student. And he is going to present on the topic Life in Space Part 1 and its challenges. Start.
Hello everyone, I'm Shrijith Niranjan from Treamis International School. I am a research scientist in Space Wanderers. Today I'm going to talk about what life in space. Have you ever thought what the life of an astronaut would be like? What are the activities they would do? I will be wondering. Why isn't it working? Yes. I will be talking about how the astronauts perform their daily tasks and discuss the various challenges they face in space. We need to understand this so that we can plan more effectively for long-term space travel, as well as improve the quality of life of these astronauts. One minute. Yes. So now So what are the precautions that an astronaut has to take before venturing into space? You must be really clean. You be ready to be confused between what is up and what is down. Everything needs to be taped or tied or else will float away. You will feel you are in water, but without the water. You'll be ready to experience dizziness and space sickness. It will be some time before you settle down. Let's start with the basic of activities. Eating. Eating in space is not easy. Since food will float around, space should not meet us. Food for space should not meet a certain criteria. They should be compact, lightweight, nutritious, tasty, sticky, and processed or pasteurized. This menu is decided based on astronauts' weight, gender, and needs, and will be between 1,900 to 3,200 calories per day. Meals need to be reheated or rehydrated. Beverages need to be rehydrated as well. You need a pair of scissors to cut the packaging open. There is a special straw to drink beverages. Make sure you catch stray food with a utensil or your mouth. Astronauts have dedicated sleep stations in the sleeping headquarters. They have a sleeping bag, a pillow, a lamp, an air vent, a personal laptop, and a place for personal belongings. Sleep bags need to be secured to a wall. You need earplugs and eye masks to block out noise and light. While orbiting the Earth, astronauts see sunrise and sunset 16 times in 24 hours. This makes it difficult for them to maintain a sleep pattern. They use GMT to keep a regular schedule and sleep for about 8.5 hours a day. So how do astronauts perform their personal hygiene tasks? The picture here shows, I forgot to move on the next. So how do astronauts perform their personal hygiene tasks? The picture here shows the toilet that is used in the ISS. You will urinate into a plastic tube and your poop goes into the waste compartment over here. The urine is sucked to be recycled and purified into drinking water. Solid waste is collected in a tank, which is then allowed to burn up when a resupply ship returns back from the ISS. You don't shower in space, but use a washcloth and a no-rinse shampoo or solution to clean yourself. Be careful about stray hairs. They can become a safety hazard for the astronaut. Washing clothes is impossible in space. Wear them until they are too dirty and then put them in the waste compartment to burn them up. Any idea how astronauts brush their teeth and shave? 1 minute. Any idea how astronauts brush their teeth, shave, and cut the nails or cut their hair?
They won't do that at all.
They do that. So this is the link for all that.
You can share
so
it
the link in this slide will provide you the details. So I'll just move to the next slide. Physical activity in space. For sake of the health, the astronauts have to do regular physical activities and exercises in space. ISS has a special gym with a treadmill, a stationary bike, and an advanced resistive exercise device, ARED in short, to keep the astronauts healthy. So how do astronauts relax during their free time? The most favorite activity is looking out of the window and admiring planet Earth. They observe storms and hurricanes on Earth. They also share their experience in space while having fun with weightlessness. Movies, board games, books, and music keep the astronauts entertained. Do you know that the astronauts get to play music in space? The ISS has a variety of instruments to play with: guitar, keyboard, flute, etc. Free time is also when they talk to their families. Here I present excerpts from the astronauts' guides for personal tasks. Has everyone finished reading?
You can share this image. They will take time.
Okay, sir.
Oh, wait a minute. I'll take a screenshot of it.
All right.
Daily water allotment 2.5 liter per day. Drinking water 0.4 liter. Daily of rehydration, preparation of food 1.5 liter for bathing, brushing teeth.
So should I move to the next slide?
1.5 liter, not just a big bottle only for bathing.
Yes, sir.
Brushing of teeth as well.
Yes. So should I move to the next slide, sir?
Yes, please.
So this slide is for managing consumable supplies. In this excerpt.
This is like a lot more crazy than Big Boss House. Each crew member is allotted 4.4 liters of water for daily use. After calculating water supply needs of the crew and accounting for the water that cannot be recycled, an additional supply of 50 liters will be placed aboard each mission for emergency use. So தண்ணீர் பிரச்சனை வந்து இங்க மட்டும் இல்ல ஸ்பேஸ்லயும் இருக்கு. அப்படிதான். That's the emergency.
That's only for emergency, Vishnoo. You don't have to drink all of it.
I won't go to space at all. I won't go to space at all.
All right, so I'm just moving to the next slide. So now we'll see the challenges faced by astronauts. Now let us look at the complex challenges that await astronauts in space. Gravity is very integral to human evolution. So for space travel, human physiology is the limiting factor. Space flights have been observed to affect the muscles, musculoskeletal, cardiovascular, and immune systems of astronauts. The changes are very similar to aging, but happen much faster in space. The more time or far the distance spent in space increases the challenges. So, what happens with the human body in space? There is a risk of radiation exposure, risk of isolation, risk of being far from Earth, then risk of extended time in microgravity, and the last risk, which is risk of long duration closed environment. Exposure to radiation. The risk from exposure to radiation is a very important one. Radiations are caused by sun, Earth's magnetic field, as well as from deeper space. These radiations can damage your nervous system, increase the risk of diseases and cancer, and cause sickness. The amount of radiation increases many times when compared to Earth's surface. It is 250 times at the ISS and more than 700 times if you are traveling to Moon or to Mars. Risk of isolation. The next big risk is from isolation. Extended periods of time spent lonely can trigger behavioral issues, impacting the work to be done. The video here talks about the risk in detail. One minute. I forgot to. Okay, the sound is. Can you hear it? Or should I share the sound?
Yeah.
Yeah. 1 minute. Now I'll just play it. 2 minutes. Maybe you'll hear it. Now continue. Being far from Earth adds to the challenges faced by astronauts in space. Delays in communication means they will have to solve problems on their own without support from mission control. Lack of proper medical care and medication increase the risk of health problems. Imagine your equipment fails in space and you are stuck with limited food and other supplies. This happened on Apollo 13 when one of the two oxygen tanks exploded on the way to the moon. The craft could only return back to Earth after circling the moon while surviving on limited resources. Scary, isn't it? Microgravity affects the bones, muscles, arteries, and immune system of astronauts. You would have seen how they walk to the rocket, but they will have to be carried when they return back to Earth. This is because microgravity impacts the ability of human cells to rebuild and regenerate. This is very similar to aging. In fact, if you go to space as a 30-year-old and spend a year there, you will feel like a 60-year-old on your return back to Earth. Imagine that. Now, long duration close or hostile environment. How are astronauts affected? These are the ways astronauts are affected. Spending long time in a closed environment like a space station or a spacecraft also impacts the astronauts. Celestial dust, contaminants, wide swings in temperature are some of the risks. The video describes these in detail. challenges to be addressed. These are listed here. Do you know of any more? Sir, you can let anyone mute if they want to. Tell any question. Sir?
No, Satyaki asked.
Okay. I'll just check it.
No, 9:30 ಆಗಿದೆ.
Sir.
Vishnoo ಅವರ presentation.
So ಯಾರಿಗೂ questions ಇಲ್ಲ?
It's very nice. It's like well detailedly. This thing. You can share this
Okay, sir.
PPT with me.
Okay, sir. I'll definitely share it with you, sir.
Yes, Vishnoo has a doubt. Yeah, he had doubts during the.
Okay, so is this question you want me to find the solution? Is it anything related to the topic, Vishnoo?
Vishnoo solve. Doubt scale.
You are saying that they can save, press, haircut, nail cut, like
Why
this,
is
they
this
will do this all things. But if that got stuck in an important machine or got stuck on any engine, means this rocket will become as a Viswanam.
All right, I'll just send the link to you. You just read it. Okay.
எப்படியெல்லாம் டவுட் வருது. ஆனா அது ஆக்சுவலா உண்மையா ஒரு நல்ல டவுட் தான். ஏதாவது மாட்டிச்சுன்னா
Yes, sir. Yes, sir. Nice question, sir. Sir, okay, Vishnoo, I'll just finish the presentation and then I'll share the link with you. Okay.
Okay, no problem.
So, if nobody has any other questions, that brings me to the end of my presentation today. In my next session, I will talk about the work being done to address these challenges.
Brilliant.
Thank you.
Super presentation. Nice. Well done. So you have any quiz?
Thank you, sir. No, sir. I don't have any questions.
Vishnoo heart attack வந்துருச்சு. Nice, nice. Let's give a huge round of applause, Vishnoo. This is Shrijith. That's amazingly made presentation. Beautifully.
Thank you, sir.
So much details.
Thank you, sir.
Well done, well done. I'll share this. I think I'm planning to share this as a separate video. So I will do it.
Okay, sir. Thank you, sir.
Presentation பண்ணி முடிச்சிருக்கலாம். Presentation பண்ணிட்டு இன்னொரு தடவை வீடியோ வேற கட்டிட்டீங்க.
Okay. That brings our last presentation of the day. The crazy theory man, Vishnoo. Yes. Vishnoo, the stage is all yours.
Okay, sir.
என்ன ரியாக்ஷன் அது? யோசிக்கிறான். ஏன்டா இவ்வளவு நேரம் வெயிட் பண்ண வச்சுட்டு ரொம்ப எந்துவா இன்ட்ரோ வர.
ஆமா ஜாதி. கிளாஸ்ல எத்தனை பேர் இருக்காங்க?
20 பேர் இருந்தாங்க.
உன் வாய்ஸ் லோவா இருக்குடா, மைக் கிட்ட வச்சு.
ஹலோ
சார்.
perfect.
தேரி பேர் என்ன?
பார்த்து தெரிஞ்சுக்கோங்க.
Thrilling. Surprise. Ta-da!
Oh, climate theory.
Climate theory.
ஏன் climate form ஆகுது? எப்படி ஆகுதுன்னு தெரியா?
Vishnoo is presenting climate theory ன்னு போட்டுறேன்.
கரெக்ட்டா கண்டுபிடிச்சாங்க.
Vishnoo is presenting.
Hey, climate, how climate is getting differ, how climate is differing. I am having a doubt.
ஏன்னா வந்து சன் கிட்ட இருக்கும்போது செம்ம ஹாட்டா இருக்கும். சன் கிட்ட இல்லைன்னா வந்து கொஞ்சம் ஹாட்டா இருக்கும்.
சன் கிட்ட நம்ம போறோமா?
சம்மர்
தூரமா தான் இருக்கும்.
சம்மர் ஆட்டம் ரெண்டுத்துல தான் வரும்.
நெக்ஸ்ட் சன் சம்மருக்கு மட்டும் சொல்றீங்க. ரெய்னி, ஸ்ப்ரிங், வின்டர் அதுக்கெல்லாம் என்னது?
ரெயின் வந்து அது வந்து என்னன்னா வந்து கிளவுட்ஸ் வந்து எப்ப ரெய்னி சீசன் வந்து எப்படி வரும்னா வந்து எப்ப வந்து கிளவுட்ஸ்ல எல்லாம் வந்து அதிகமா வந்து வாட்டர் வந்துச்சு அது வந்து மழையா பெய்ஞ்சிடும். ஸ்னோ வந்து ரொம்ப கூலா இருக்கும் போது வந்து
Okay. Actually, this theory contains two theories.
வின்டர் சீசன்னா நம்ம சன்னை விட்டு தூரமா வரனால அது வின்டர் சீசன்.
Okay. Good. But can you believe or it's just an opinion? This theory is just an opinion for me. So நான் உங்கள்கிட்ட ஒரே ஒரு கேள்வி மட்டும் கேட்குறேன். இந்த கிளைமேட் சேஞ்ச் ஆகுறதுலாம் கிளவுட்ஸ், இந்த மேகம், இதாலதான் கிளைமேட் சேஞ்ச் டிபெண்ட் ஆகுதா?
அப்ப எனக்கு ஒரு டவுட் கேக்குறேன். அப்ப எப்படி சன் கிளவுட்ஸால சேஞ்ச் ஆகுன்னு சொல்றீங்க, அப்ப எப்படி கிளவுட்ஸ் வந்து சம்மர்ல வந்து ரொம்ப ஹாட்டா இருக்கும், அது எப்படி கிளவுட்ஸால ஹாட் ஆகுதா?
தம்பி 1 minute wait a minute. அத பத்தி தான் பேச போறேன். பொறுக்குன்னா அது கேள்வி கேட்கக்கூடாது, பதில் சொல்ல தெரியாது.
So tell what's your doubt?
Okay. First, cloud theory. How clouds are formed?
How clouds are formed?
Clouds வந்து solar system contains or emits, especially Venus, Sun, the hottest planets. They will emit gases too. So, sorry. So, space, solar system emits gases, especially Sun, Venus, the hot planets. So these planets will get emit gases. So they will group. They will form a group. Group means
what group?
Group of gases, mound of gases. Gas எல்லாமே சேர்ந்து ஒரு பெரிய ஒரு ரூபமா வருது. Mound of gases இப்படியே சொல்லலாம். So
அது வந்து வாட்டர் வேப்பர் வாட்டர் சைக்கிள் ஆகும்போது வாட்டர் வந்து cloud-ஆ மாறி இருக்கும்.
வாட்டர் that's only in earth. Earthல வந்து it's water, it's made of water. When you go to Titan, it's made of methane clouds. When you go to Venus, it's different. So each planet has different combinations.
Okay.
That helpful. Okay. இதெல்லாம் combine, அதாவது these gases will get combined, or it will get combined as it is. So it will join or it will enter any planets. See here in this area, Earth, a cloud, a mound of gas gone inside Earth. So because of the ozone layer, it became as a cloud. Okay, well, they can go inside the layer because they are as density of air is the density of gases are higher. So they can go inside and they can go enter and exit. So they can it can go inside the layer of the planet by their huge density of gases. Okay, then how rainy season is formed? Rainy season is formed by 1 minute, sir. Rainy clouds are formed if they get heated by sun's heat, sun and the planet's surface temperature, like a Shanghai coffee. Shanghai coffee means it's a cotton candy. It's a recipe by China. The cotton candy will be placed will be placed above a hot coffee. So the coffee's vapor enter the cotton candy and it got melt and it will cotton candy so the coffee will become as a sugar. So this is what Shanghai coffee. So like this rainy season is getting happen. The surface temperature, the sun's heat attacking a cloud constantly. It will get melted, which is rains. So next one, spring season, summer. Summer is what we know. Summer is clear sky or no cloud. There will be no clouds. மொட்டை வெயிலா இருக்கும்பாங்க அந்த மாதிரி. As you know that
clouds பார்த்திருக்கேன்.
செம்மையா இருக்கும்.
It's why because the clouds are dense full and can go outside the layer too. Already we have discussed about this. And the sun heat is too much. That's also. And the clouds are sheets and create a shadow over there. அதாவது இப்போ ஒரு clouds are just a layer or a sheet cool. It will make the temperature of the surface in the planet. It will reduce the temperature if there is clouds. If there is no clouds, because of the sun heat, it will get we will get affected by the sunburn. Like this, we will get affected because of the sun heat. If there is clouds, we can help. It will help us by providing sun from attacking its heat or light. So if I said that clouds can enter and exit from the layer because it is dense full. So it will go to space if at that time if the clouds go to space, that is summer season. So next spring. Spring is what if the new cloud enters our earth. If a new cloud enters our earth or it is going out from our earth, the pressure will give us a wind. So that wind is a strong that breeze. So it will make the new flowers to bloom, new fruits to bloom, and shed all the dry leaves, and like this make the dry leaves to fall. So the clouds, if they enter or exit at the time, the wind will hit the plants. That in that particular period, we are saying it as a spring season. So next one, winter. Winter is what if all the clouds join together and it is having a time. It's having more time to go up to the face, means as we know that it's a cover still cool cover, so it will make the surface temperature cool and it will make the land frost freeze chill, like that it will give like that. So if there is more clouds like this, less sunlight occur, means it's a winter season. That's all. So many doubts can come even from sir.
So எனக்கு தெரிஞ்சு இன்னைக்கு டவுட்ஸ் கம்மியா தான் வரும், நாளைக்கு தான் நிறைய டவுட்ஸ் ஆகும்.
This is the correct English.
Okay. So nice theory. இதுல இப்போ எர்த் பேஸ் பண்ணி நிறைய சொல்லியிருக்கல. So it will change for different planets, different moons. Yeah.
Not only depend on the planet we are residing, it also depends upon the efforts of more elements.
Yeah. Okay.
Any doubts?
Harijit, உன்னோட கேள்வி கணக்குகளை கொடுப்பேன். யோசிக்கிறேன். So climate theory. So எதனால climate theory மாறுது?
எனக்கு ரெய்னி சீசன் புரியல.
ரெய்னி சீசன்.
கொஞ்சம் சிம்பிளா
One
சொல்லுங்க.
minute. One minute, Harjit. See, if the clouds are there in the Earth or planet, the surface temperature and the sun's heat matters to clouds to melt. தமிழ்லேயே சொல்லிடுறேன். இப்போ ஒரு பிளானட்டு, அது இறங்குற பிளானட்டோட சர்ஃபேஸ் டெம்பரேச்சரும் சன்னோட ஹீட்டும் அதிகமாக படப்பட அது மெல்ட் ஆகி கீழே வாட்டர் ட்ராப்லெட்ஸா கீழே விழுகிறது தான் ரெயின். புரியுதா? சங்காய் காஃபிங்கிறது ஒன்றும் இல்லை. இப்போ
எனக்கு ஒரு क्वेश्चन விஷ்ணு. எப்படி இது கேஸ் மெல்ட் ஆகும், சாலிட் ஐட்டம்ஸ் மெல்ட் ஆகும்?
ஏன் அது எப்படி சொல்ல முடியும்?
கேஸுக்கு மேல ஒண்ணும் கிடையாது. கேஸுக்கு மேல ஒண்ணும் கிடையாது. கேஸ் தான்.
கண்டென்சேஷன்.
Clouds na basically it is like அது எப்படி சாலிட்னு எடுத்துக்க முடியுமா நம்மளால?
சாலிட்னே எடுக்க முடியாது சார். இட்ஸ் கேஸ் only, visible gas.
So it breaks down basically, the clouds break down. Correct?
ஓகே, புரிஞ்சிச்சு விஷ்ணு. அது வந்து கிளவுட் இருக்கும், அது வந்து சன்னோட ஹீட்டால கிளவுட் வந்து உருகி வந்து வாட்டர் டிராப்லெட்ஸா ரெயினியா மாறுதா?
கண்டென்சேஷன்னு சொல்ல எனக்கு புரியும், ஆனா இது கிளவுட்ஸ் மெல்ட் ஆகுதுன்னு சொல்லாத.
வேர்டிங்ஸ் மாத்தணும். So basically the cloud breaks. So cloud வந்து உடையுதுன்னு வச்சுக்கலாமே. All this water எப்படி so basically what is cloud? It's a combination of all this water vapor molecules இல்லையா, ions.
Yes.
So what is water? What is cloud?
Water vapor sir.
Okay. So water vapor எல்லாம் ஒண்ணா சேர்ந்து அது ஒரு ஃபார்ம் ஆகுது, நம்ம கண்ணுக்கு வந்து தெரியுது.
ஆமா, கேஸ் வந்து லிக்விடா மாறுதா?
எஸ் சார்.
அதான் விஷ்ணு சொல்றான். அப்புறம் லிக்விடா மாறி அது வந்து லிக்விட் வந்து வாட்டர்ஸ் வந்து வருது கீழே கிராவிட்டியால.
சரி.
அந்த ரெய்னி சீசனுக்கு நடக்கிறது இது நிஜமாவே நடக்குது. அப்படிதான் நடக்குது.
He is coming up with a new perspective. நம்ம இப்ப ரெகுலர் சயின்ஸ்ல யோசிக்கிறோம், அதே வேற மாதிரி யோசிச்சு பார்க்கலாமே. சோ இத பத்தி நம்ம திரும்ப டிஸ்கஸ் பண்ணுவோம். நெக்ஸ்ட் செஷன்ல வந்து திரும்ப அதை டிஸ்கஸ் பண்ணுவோம். நிறைய பேர் இருக்காங்க.
ஓகே சார்.
Thank you.
Okay sir, bye sir.
Thank you audience for watching us. We will catch you on next chapter number 28 on next coming Saturday, Sunday. Bye.
Bye.
Bye, Jaku.